Hello and welcome to another video. This is Brent Raymond from 4D Method, 4D and Wakanda User Group. You can find our website at 4dmethod.wordpress.com or email us at 4dmethod@gmail.com. This demo will show a way to set your 4D field indexes to the correct index type for a field. In 4D, an index type can be set for an index field, and those types include B-tree, cluster B-tree, or automatic. You set those here in the field properties under index. They default to automatic. There's always been some question about how automatic works. How does it know what to do? What does automatic do? How would it know, considering it doesn't see your data in this part of the design phase? The differences between the two index types, there's B-tree, which is best used for when there's a high percentage of unique values to total record count, total field values. And there's cluster B-tree, where there's a low percentage of unique values. It's just in the way that the algorithm works for creating pages of the index. An issue came up in a recent training session in Chicago from JPR. It could have been lost in translation, but it was highly suggestive that that if fields are set to automatic, as they default to, both the B-tree and the cluster B-tree indexes will be created and maintained for the field. 4D would apparently switch somehow when one is used, which one is used based on their algorithms, but only for a limited number of field types. So it occurs to me that normally we do know what our data set looks like when we have a 4D application. Not only that, but the calculations to determine which index type should be used are trivial, and we can dynamically analyze the data to see which indexed fields have what kind of data and measure the uniqueness of that data to see if you need to be using a clustering algorithm or just a B-tree. You can also analyze your structure to see what the field types are. Some field types are obviously going to be clustered, like Boolean, and you can also see which field types are storing a foreign key or are part of a relation, relate one to many kind of relation where you'll have predictably batches of values there. Okay, so getting back to my demo database, so I can show you some code. Here's the structure. I just created a few fields, including an auto-incremented ID, which of course will have all unique values. It's defaulted to unique. We have a Boolean field here, all these with automatic indexes, a long and another long. And there's a method to generate sample data for this table. All it's doing is creating a variable number of records, in this case 10,000, and creating an array for unique values for the second long field, and then pushing 10,000 new records onto the table. So let's go ahead and run that. Okay, records are successfully generated, and now we have, if I can minimize this a little bit, and now we have this many records in the table, 20,000. because I just ran it. So this is the second time I've run this method. Right, so now we've got data, we've got a structure, we've got data. Just to be sure, there's also a method in here to set the indexes back to automatic, so that if you have if we run the auto indexer index typer and you want to revert that back to automatic, you can do that, or you can just revert back to a backup, which is probably wise. So let's go ahead and run this. Okay, that's done. We do have all automatic indexes. Okay, now let's go ahead and look at the method for auto setting the index types. So here's the method, and here's the rules that I've set up. Set it to a cluster if it's a Boolean type. Before I go on, I just want to say this is loosely based on Tim Neville's NUG code from the following link. That served as a good basis for creating this logic. So set all Booleans to a cluster field. If it has a choice list attached, a 4D choice list, set it to a cluster. Set it to a cluster if it's detected as a foreign key by name, say _F key, or it can also detect it by a relation, as we'll show lower. I currently have this disabled. Again, this is just a suggestion, code for you to take and edit to however you'd like to use it. Now there's a couple rules for that I've heard for when you should set a field to clustering. I've heard that if the ratio of unique values to all values in the column are less than 12% of the table, represent less than 12% of the table, or I've also heard that there's fewer distinct values than 1/32 of the record count. May be redundant to the prior rule, but both of the logics are in here, and we use both the logics. And I'm up for more suggestion on how to intelligently detect whether a field should be clustered. Oops. I also added a couple rules of my own. Set it to a cluster if it has fewer than 5 distinct values, because we have a few instances of that which were getting pushed to B tree. And it can be argued either way which index those can be. Again, these are only suggestions. Set all automatic or default type indexes to B tree. Now, that's the remaining, once you've covered all the cluster fields that you're sure that you've caught all the clusters, then if there are any remaining automatic ones, then they should be defaulted to B tree. Again, this is just to dictate to 4D that you don't have to store, if you're going to do that, or any time in the future, if 2 indexes need to be generated and maintained, which does have some processing cost, we're going to dictate clearly which index type that we want to use. And finally, if it's a unique field, set it to a B tree. All of these, you can add your own rules, move these rules around. I believe that they're in case order, so these are the priorities that are basically set. This method can be run in 2 different ways. Either way, it'll return a list of the modifications that it intends to make and or did make to your structure, and pass true to this method to actually execute the modifications. So you can run it, see what it wants to do, go check that out, does it make sense, and then run it again and actually log a report. If you have logging in your system, which would be a good idea, you can store the log of what indexes were changed, and then you could even run this on a regular basis to to update the indexes as your data changes. Okay, so coming down, we just have our variable declarations. We have our parameter declarations. We are looking at the default index seems to be able to have two different values. One is 7 and the other one actually has a constant below. We have two loops here, looping around the tables if the table number is valid, looping around the fields in the table if the field number is valid. Then we're getting our field properties. We're pulling the index type from the SQL table from user indexes. A little trick of how to do that. It's very handy. Then we're also getting the field types to see if it's set to be mandatory, enterable, non-modifiable, those kind of things. In this case, we're looking for the choice list. Here is the code for determining if the field is a foreign key. You can either go by naming convention for your own system, or you can get relation properties and see if it's the one table of a one-to-many relation. I have this disabled just because it was I wasn't prepared to turn that on for myself. Just playing with it to see what results would come out, and you can activate that if you like. Okay, coming down, we've already covered foreign key, choice list, and Boolean, because we'll have standard rules for those. And this is where we are measuring the uniqueness of each of the field types. Now, this as different field types are created and made indexable in 4D, you'll have to update this to handle additional field types. For instance, I don't have the date field covered in here. The object field will have a whole new bunch of kinds of indexes, and so on. So this is code for expansion, but for simple databases this works, and it's just an example of how you would do it. So you're calculating the number of distinct values in that field for those records, and you're calculating the ratio, and you're deciding whether you should cluster this field based on the combination of those rules. Now, I also added in here, no matter what the condition is, for instance, if there were very few records in the table, don't cluster it if it's my P key field. Don't change my any of my primary key fields to a cluster index. I want those all to be B tree. Okay. Now we're coming through and making decisions on what's going to happen. Most of this looks like more code than it needs to be. That's really just because it's calculating the result, the text result of what it's going to do, and setting the new type based on a combination of a couple different logics here. If it's a Boolean field type and it's not already a cluster B tree, then set it to a cluster B tree, and so on. If it has a choice list and it's not a cluster, make it a cluster, and all of those changes are being made note of here in plain text for you to store in a log. So on and so forth. Just like the rules that were commented above, we're just ticking through each of these cases. The rest of these will become standard B trees, including the automatic type, which is the mystery automatic type that we may as well just set it. If we can figure it out, we ought to set it to the type that we want. And other things like the catch-all for the unique values is unique, or it just needs to be a clustered tree because of our calculations. Oh, sorry. In this case, it's a cluster, and it shouldn't be a cluster because of our calculations. Sorry about that. Okay, and then here's the actual code to set the index. We delete the old index, and then we set it to the new type. And you only do that if you have flagged to execute the index modifications. And currently, since I don't have the my logging code in this demo database, I'm just pushing the result to the pasteboard. So we'll open up a pasteboard and go ahead and run this. And there's our website, handy dandy website. Let's go ahead and run this through so we see that it finishes. Okay, that's wonderful. And in the clipboard, these are the modifications that it wants to make. Now let's go look at our structure. It didn't make those modifications yet, but you can see what it wants to do. Set the automatic for the table ID. In this case, it's not peaky, but we're setting it to a standard B tree. I say it's not a peaky because it's not named peaky, as is the Art Institute's convention. The Boolean field will be set to the cluster. The first long will be set to a cluster because actually all the values are 0. So they will all records will go into one page. And then the second long will be set to a sorry, that's vice versa. Will be set to a standard B tree. No, right, that's right. So the first one is a cluster, and the second one will be a standard B tree because it has all unique values as we put them into the as we created the records. We created unique numeric values for the second field. Okay, great. That's good. Well, let's actually run the code and see it work. Okay, so we ran it with the true, execute the field changes. Oops. And now let's go back and look at our structure. Okay, now we have B tree, cluster, and B tree. So we've removed all automatic indexing from this structure. Now, it should be noted that you can now, you have to regenerate your index file. It's best to regenerate your index file to save the space in memory that you're going to save, because the cluster index files, cluster indexes actually take up or should take up less memory if they're being used appropriately. Yeah, so you'll need to shut down the database, delete the index file, restart, and let it re-index. So that would allow for the most efficient use of the memory in the application. So yeah, I won't do that right now, but I assume if you're watching this video, you know what I'm talking about. Right, so you'll save space in your RAM for doing this, potentially a lot. And it's still important in 4D, even though we have 64-bit servers. On Macs, we're still inching up to being able to have 64-bit servers and having virtually unlimited RAM, but most people haven't gotten there yet. And in addition to saving more memory, you'll perhaps have see some speed increase, but the memory savings and basically just doing things right will have the best result for you. Remember, back up your structure before running these things in your database. And I didn't have them in there, but confirmation dialogues are generally good ideas before you run this code. Are you sure you want to change your index types? Perhaps run it with a false first. Say, this is what you're going to do, and then run it with a true if they say okay. Anyways, this is Brent Raymond again with the 4D Method user group, and I hope you enjoyed the video, and the demo database will be made available on our website. Thanks so much. See you in the next video.